Steel, cold, rigid, and unyielding is where it all begins. Inside the fabrication workshop, workers measure and cut long lengths of rebar, following precise blueprints tailored for each transmission pole design. Bar by bar, they bend the steel to exact angles using hydraulic jigs, then tie intersections tightly with steel wire. Every weld is checked, and each joint is inspected, since even a minor flaw could mean disaster decades later under harsh weather. Some cages for larger poles stretch over 12 meters, bristling with main bars and closely spaced stirrups, creating an intricate latticework that's both beautiful and intimidating. Reinforcement specialists make sure additional ties are placed at points of maximum stress, especially at mounting bases and connection nodes. It's impressive to see these steel skeletons lined up, each a backbone and waiting. Technicians walk the rows, double-checking alignments, measuring bar cover, and making final adjustments. This stage sets the foundation for the entire pole's strength and flexibility. The reason transmission poles can stand up to heavy wind, ice storms, and shifting soil for decades. Next comes concrete batching, a carefully engineered process where nothing is left to chance. Silos release fine sand and gravel onto conveyor belts, which carry the raw material to massive mixers. Cement is weighed out precisely, and water is added with exacting care. Special chemical additives are dosed to improve the finished concrete's freeze resistance and long-term durability, crucial for the harsh Russian climate. As the mixer churns, quality control teams run tests on sample batches, checking for slump, air content, and aggregate distribution. Sensors monitor moisture content and adjust mixing times. When the perfect mix is ready, it's poured into the steel cages already set within sturdy molds. Once curing is complete, the formwork is unlocked and heavy-duty cranes carefully lift the finished pole free. Every movement is slow and controlled. The pole's mass demands absolute attention as it swings clear of the mold. This union of thoroughly crafted steel and expertly batched concrete is the foundation for power transmission that will endure for generations, a powerful demonstration of engineering precision and industrial pride. Street cleaning rarely looks this powerful. The Wolschlager cleaning vehicle rolls in, fitted with high-pressure water jets, powerful suction, and a robust rotating brush system. The process kicks off by washing the road surface. Jets blast stubborn dirt from cracks, while large brushes sweep up debris. As the machine moves forward, it targets storm drains and manholes, deploying a boom that lifts heavy covers and uses focused nozzles to break apart built-up sludge. Watching the water spiral down the shaft, you can almost feel the pressure. All removed material is vacuumed up through a large diameter hose into secure onboard tanks, leaving no mess behind. Next, the vehicle shifts to large open surfaces, sidewalks, plazas, parking lots, scrubbing away every trace of grime. The operator monitors everything through cameras and gauges, making real-time adjustments to water flow and brush speed for maximum efficiency. When it's time for sewer cleaning, a flexible hose is inserted deep into the channel, where it blasts away obstructions and flushes out sediment. Drains for rainwater are drilled and flushed, preventing blockages and maintaining smooth flow. Every step is coordinated to minimize disruption and maximize cleanliness. Seeing urban infrastructure get this deep clean is strangely satisfying. Behind the noise and water, there's precision, technique, and a kind of industrial grace at work. steel giants don't just appear, they're crafted step by step, and LNG vessels are among the most complex ships ever built. It all begins with massive steel plates delivered to the shipyard. Each section is shaped and pre-assembled in workshops, where welders join them into giant modules. Every weld undergoes non-destructive testing to ensure flawless seams. The ship's double-hull structure, critical for insulation, is then assembled section by section using heavy-duty cranes. Specialized teams install layers of insulation, often over a meter thick, between the inner and outer hulls to safely contain liquefied natural gas at -162 degrees Celsius. Engineers route miles of pipes and cable trays throughout the vessel, connecting control systems and gas handling equipment. Enormous LNG storage tanks, prefabricated with nickel-steel alloys, are precisely lowered and fixed inside the hull. The sheer scale of these vessels is awe-inspiring, with some exceeding 300 meters in length and able to transport enough LNG to power an entire city. On deck, advanced navigation and safety systems are installed, while massive engines and propulsion units are lowered into the engine room. Once the vessel is structurally complete, painters coat the ship with protective layers to guard against corrosion at sea. The final phase includes rigorous sea trials. Every function is tested under real-world conditions before delivery. Witnessing this transformation from steel to sea-ready vessel is truly impressive. Every detail reflects years of expertise and teamwork. Beneath the St. Croix River's calm surface lies a foundation built for the ages. Construction crews started by floating in a massive prefabricated steelwork platform, carefully aligning it above future pier locations. Through giant openings, steel casings were driven up to 150 feet down, cutting through water, muck, sand, and soft sandstone until reaching solid bedrock. Excavators then removed tons of debris from inside each casing, and massive drills pushed even deeper into the rock for stability. With the casings clear, workers installed huge rebar cages and poured concrete, locking each caisson into place. Cofferdams were then lowered to create dry zones underwater, allowing precise concrete footings to be built. Watching the columns rise out of the river is a testament to engineering pushing limits. These underwater supports will anchor the bridge for a century or more. Concrete construction is getting a major upgrade, and it's wild to watch. In this experiment called Spacecrete 2.0, a full-sized building is made using pumped concrete walls without any formwork. Instead of shaping walls inside molds, the concrete is simply stacked, one pass at a time. The process starts with a standard mix from a batch plant. Then, about 10 to 15 feet before it exits the pump, two key additives are injected, a thickening admixture and an accelerator. This combination activates an old version of their 3D admix system, transforming ordinary concrete into a printable material that stiffens just enough to hold shape as it's stacked. A guided screed tool follows behind, vibrating each layer where needed to ensure strong bonding. Foam panels placed along the sides help keep everything straight and clean. The whole process feels like watching construction and 3D printing collide in real time. Raw, mechanical, but strangely precise. The result? Vertical walls that are 13 feet high and just 4 inches thick, built without forms, poured in one continuous motion. It's not just a technical feat. It's oddly fun to watch. There's something strangely satisfying about how precisely the layers build on each other with almost no sag or slump. Every bit of concrete used in the walls is thermally isolated from the exterior and ground, meaning all the thermal mass stays inside the conditioned space where it actually contributes to energy savings. There's no wood, no organic material, nothing that can rot or burn. That makes this approach ideal for passive design homes aiming for net zero energy. After months of exposure to the elements, the results speak for themselves. No cracking, no shrinkage. That's not easy to pull off, with rich mixes curing in open air, but here the shrinkage control mechanisms exceeded expectations. Earlier mix designs favored faster pumping, but allowed minor shrinkage. This version slows the stacking slightly, but keeps everything dimensionally stable. They're now working to combine both strengths, rapid flow and no shrinkage, in the next version. This is just the first full-scale test, but it already opens new possibilities for fast, durable, and affordable construction. If the next iterations deliver as expected, this could seriously shift how walls are built around the world. Watching decades of grime vanish under high-pressure water never gets old. In this process, the dockmaster and dockboy hydroblasting units work in tandem to clean a ship's hull with stunning precision. Dockmaster handles large vertical surfaces using remote-controlled arms, while dockboy navigates tighter areas with greater flexibility. Both systems blast water at pressures exceeding 2,500 bars, stripping off paint, rust, and marine buildup without damaging the steel. The surface is left clean, textured, and ready for coating, all without manual scrubbing. It's oddly satisfying to see layers disappear like peeling old skin. Efficient, powerful, and consistent. This method keeps maintenance safer and faster for massive vessels that demand flawless upkeep. Precision and power come together in this track demolition project on Rami-Strasse, Zurich. The goal is clear. Remove the tram rails and related infrastructure between addresses 18 and 35 efficiently and safely, minimizing impact on nearby urban utilities. Every step is carefully planned to avoid disruption in this busy city area. The Komatsu PC 210-10 takes over, using its clamshell bucket to scoop up the debris and load it into waiting dump trucks with smooth, controlled motions. Material handling doesn't stop at removal. Concrete chunks are sent for crushing, metals sorted for recycling, and old rails cataloged for reuse or proper disposal. This closed-loop approach not only benefits the environment, but also optimizes resources for future projects. The Hitachi ZX 670-3, equipped with a robust hydraulic hammer that breaks through thick concrete slabs with relentless force. The sheer sound of steel hammering concrete echoes through the city, a rhythmic reminder of heavy industry at work. Following this, the pace of work is relentless, yet every operator maintains precision to the millimeter. Two Liber A918 excavators, including a compact variant, work in tandem to clear the ballast layer beneath the tracks. These wheeled machines move with surprising agility, maneuvering within tight urban confines to separate materials that can be recycled or discarded. The care with which they work, underlines the balance between brute strength and precision engineering required in urban demolition. Before any physical demolition, the team uses advanced surveying and digital mapping to confirm the exact layout of underground utilities, guaranteeing these critical systems stay unharmed during the process. This attention to detail reflects the modern demands of urban infrastructure projects. Supporting these giants, the Takeuchi TB295W2, a more compact excavator, handles finer details near curbs and edges, breaking up smaller chunks of concrete and ensuring no debris is left behind in tricky spots. The choreography of these machines feels seamless, each piece working with perfect timing, avoiding unnecessary downtime or overlap. Watching these machines coordinate so flawlessly is a reminder of how far construction technology has evolved. The synergy of skilled operators and powerful machinery is a testament to how modern demolition blends raw energy with exacting control. It's an impressive display of efficiency and respect for urban surroundings, proving that even destruction can be carefully orchestrated. Steel rises fast in this massive distribution center at Papamoa. Jensen Steel fabricators crafted a Steltec portal frame structure, painted in the iconic mainfreight blue. The project used an astonishing 900 tons of structural steel, expertly fabricated and assembled to create a durable, spacious facility. Watching these steel giants take shape is impressive, each beam precisely cut, welded, and fitted. This is a testament to skilled craftsmanship meeting large-scale industrial demand. Track laying reaches a new level of efficiency with the S2PV system at Neuville-de-Poitou's Grand Pont site. This cutting-edge technology redefines how quickly tracks can be installed without sacrificing quality. Over 11.6 kilometers of new railway track are being installed using this innovative method. Panels measuring 18 meters are pre-assembled at the worksite base, ready for rapid deployment. Preparation at the base ensures that assembly errors are minimized and installation runs smoothly on site. 2 panels are loaded onto the LMC trolley, which can switch between rail and caterpillar modes, enabling smooth transport directly on the ballast without needing special runways. Controlled remotely by 3 skilled operators, the system precisely positions and lays each panel in place. The remote control system provides excellent visibility and fine control for operators, reducing the risk of mistakes. The PEM XL lifting units handle heavy panels, making sure they're perfectly aligned before being set down. Each lifting unit is designed to manage massive weight safely, contributing to site safety and efficiency. The process repeats panel by panel, ensuring consistent quality and speed. Over 645 panels are laid in this project, with every move carefully coordinated. The connection ramps facilitate smooth transitions, and the entire system's radio control allows seamless operation across the worksite. Coordination of multiple components and operators showcases teamwork at its best. This method drastically reduces installation time. Only 15 days are needed for the entire 11.6-kilometer stretch. It's a prime example of technology and teamwork, combining to modernize railway infrastructure while maintaining strict precision and safety standards. Watching the panels glide into place is a glimpse of the future of railway construction, where speed, accuracy, and automation rule. Steel construction is both an art and an engineering feat, perfectly demonstrated in this production and assembly process by Stalcon. The project takes place in a massive workshop spanning 6,500 square meters, featuring 2 painting and blasting chambers, each measuring 30 meters long, 8 meters wide, and 8 meters high, spaces designed for high-quality finishing. Heavy cranes, including a shiploader capable of handling 1,000 tons, assist in moving large, complex steel elements through each stage. The steel components, ranging from lightweight frames to heavy and large-dimensional structures, are thoroughly fabricated following custom designs. This includes bar and frame overhead cranes, pipe cranes, stackers, harbor devices, and industrial tanks. The welding process is executed with exacting precision, using automated and manual techniques to create strong, flawless joints that guarantee structural integrity. Each piece undergoes blasting to remove impurities, followed by precise painting inside controlled chambers to ensure durability and corrosion resistance. Assembly requires both heavy lifting and exact alignment, often aided by advanced machinery and skilled technicians. Watching the transformation of raw steel into functional, massive structures is truly impressive. Every weld, bolt, and painted surface reflects years of experience and high standards. The synergy between human skill and technology brings steel dreams to life, building the backbone for industries and infrastructure worldwide. The TECSA system revolutionizes high-speed railway track mounting with innovation and speed. Since 2006, this patented method has drastically shortened track installation times while maintaining precision and quality. Its development reflects decades of engineering research aimed at optimizing railway construction efficiency. The process begins with setting out secondary network landmarks and saddle points for accurate alignment. Data is collected on-site to verify and adjust the construction line. Sleepers are then distributed along both sides of the platform to prepare for laying. Unlike traditional systems that require building a costly auxiliary track with heavy sleepers, the TECSA system unloads the rails directly onto the railway sleepers using a rolling lateral unloading gate. This eliminates the need for auxiliary tracks and speeds up installation. This reduction in intermediate steps significantly cuts costs and labor intensity. The system's impressive performance is evident in its output. The new method achieves 2,160 meters of track mounted on the leading track, compared to 810 meters with the traditional approach, a 266% increase. On the parallel track, productivity jumps even further to 3,240 meters, 400% more than before. TECSA's method allows simultaneous extension of track and sleeper placement, streamlining the workflow. The entire operation is controlled with advanced machinery, ensuring precise positioning and smooth transitions. This innovation was successfully implemented on major Spanish high-speed lines, including Madrid-Saragossa-Barcelona. Its combination of reduced installation time and enhanced track quality positions it as the future standard for high-speed rail construction. Watching this system in action offers a clear view of how modern engineering, automation, and teamwork are reshaping the railway industry with unmatched efficiency. The Port of Aberdeen is stepping boldly into the future with its massive South Harbour expansion. This project, one of the UK's largest marine developments, involved years of planning, environmental surveys, and engineering precision. From dredging the seabed to fabricating and installing thousands of massive concrete electrodes weighing up to 36 tons, every step demanded exacting care. Advanced dredgers like the Goliath ensured deepening without blasting, protecting marine life with innovative bubble curtains. Construction teams worked through challenges, including pandemic delays, yet progress never stopped. Now the port accommodates larger vessels, boosting local economies and energy sectors. Watching this transformation is inspiring, a true testament to resilience, innovation, and vision shaping Scotland's maritime future.